Today we are going to discuss about how to find out the reaction forces in the case of 1D bar element. So we have the equilibrium equation as the stiffness matrix into displacement vector, which is equal to the force vector. From this equilibrium equation you can find out the reaction forces which is acting at the contacts. So reaction forces can be calculated by the using equilibrium equation. I will shift this force vector to this side, so that expression can be helped to find out what will be the reaction forces. So this is the equation or expression to find out the resistance reaction forces. So let us take one element. So here it is a model with one element, so it containing two nodes. So that as how we are finding out the displacement, in the same way we are finding out the reaction forces. So after finding out, suppose here we have u1 as well as u2 at the node 1 and 2. So first of all we will find out what will be the u1 as well as u2 from the equilibrium equation. After that, in the problem they will ask find out what is the reaction forces. So same way how we are finding out the displacement, same way we have to find out the reaction. So at the node 1 we will take this as R1, and same way we will take this as R2. So I will write down this formula, that is I will write down the vector R1 as well as R2, which is equal to stiffness matrix. Here we have the two node, means it is 1 2 by 2 matrix, 1 2 1 2, and here the displacement will be u1 u2 and force which is acting at the node 1 and node 2. If you substitute all the values, then you can easily find out what is the reaction forces at node 1 and node 2. Just remember that wherever it is fixed, there you can have the value. Suppose if the node 1 is fixed, node 2 is free, and node 2 experiencing the force, in that case you can only have the value of R1, not for the R2. It may be equal some around, it may be some smaller value if you compare to the R1. So this value of R2 will not be that much important compared to the R1. So only you have to find out what is the value of R1 wherever the contacts are there. So if I take the structure which is made up of two elements, here I will take one element, and it is here two element, second one, and node 1, node 2, node 3. If I take the stiffness matrix, I have to combine here K1, K2. I will write down the overall stiffness matrix, which is having 1 2 3 1 2 3, means it is 3 by 3 matrix. Same way I will write after finding the u1 u2 and u3 values. If the u1 is 0, no need to find out, but need to find out u2 as well as u3. After getting the values of u2 or u3, then we will move to find out what is the reaction forces. Same way at the node 1 I will take R1, at the node 2 R2, at the node 3 R3. That I have to write. While I am substituting the same equation here, I will write it once again. The reaction force will be equal to the stiffness matrix into the displacement minus of force vector. So I will substitute the same all these things in that equation. So here I will write as R1, R2, and then R3. It's a vector. Then write the stiffness matrix which is of 3 by 3. Then you have to write down what is the u1, u2, u3 minus forces. Here I will take F1, F2, F3. Wherever the force is given, that you have to substitute the same value. And if a structure is made up of 3 elements, in that case same way I will write here as first element, second element, and third element. So nodes are 1, 2, 3, 4. 1, 2, 3 and 4. Here overall stiffness matrix will be, it is 4 by 4. 4 by 4 matrix. So that I will write, after finding out all the unknown displacement, if u1 is known, then you can find the u2, u3 and u4. Okay, after finding out, next you have to find out what is, if they ask what is the reaction force, in that case you take at the node 1 r1, r2, r3 and r4. So once again I am going to use this equation to find out the reaction forces. I will substitute all these reaction forces in that expression here: r1, r2, r3, r4. It is equal to overall stiffness matrix. It is overall stiffness matrix, and then here it is u1, u2, u3 and u4. Then here minus, it is force vector f1, f2, f3 and f4. This is a way how we are finding out the reaction forces.